morning, everyone. In this video, we want to prove first derivative property of Laplace transform. Amen. Just follow me. Make sure you like this video, share it, subscribe to my YouTube channel. Thank you and God bless you. Okay. How can we prove the first derivative property of Laplace transform? Okay, let's recall. Let us prove. Let us have our first derivative, that is, if we have Laplace of the f of t all over the t, okay? Amen? This is what we want to look at, okay? So, let's first define Laplace transform mathematically. Laplace transform is defined mathematically by Laplace of t is equals to integral 0 to infinity exponential minus st f of t dt. Amen? Okay. So it means we are going to derive the first derivative properties of Laplace transform using this definition. Okay. So let's go. Okay. Note that your f of t is this df of t all over dt. Amen? So take note. So now we write Laplace transform of df of t all over dt will now be equals to integral 0 to infinity exponential minus st df of t all over dt times dt. Amen? Okay. So now, what are we going to do first? Let us ask ourselves this question. You know, if you come across integral of this form, what you need to first remember is go back to your integration where we have integration by parts, two of us. So the reason that is how we can solve this integral, we are going to apply what is called integration by parts. So we now write using by parts or integration by parts, whichever way you want to write it. Integration by parts, that is integration by parts, this formula is u dv is equals to uv minus integral v du. Take note. Is that clear? Okay. So if you agree with me, it implies that you don't need a prophet to tell you this is how the integral is. We now say let u be equals to exponential minus st. So let us differentiate this with respect to t. Our du all over dt is going to give us minus s exponential minus st. Two of us. If you are good at your differentiation, this is what you are going to have. So our du will now be equals to minus s exponential minus st dt, because if you cross multiply. Okay? Then let us let our dv, because our u is this remaining dv, let dv be equals to the first derivative, that is df of t all over dt, amen, times dt. So if you integrate both sides, you are going to have a v, then you are going to have f of t. Is that clear? So now we are going to substitute these parameters into this formula. Okay? Let's do it together. Let's do it together. Amen. Okay? So if you can see what I am saying, it means our f u v is equals to uv. What is our ordinary u? Our ordinary u is this exponential minus st times our ordinary v is what? F of t, two of us. Mind you, this integral is, we have a limit running from 0 to what? Infinity. So don't forget the limit 0 to infinity minus integral 0 to infinity. What is the ordinary v? Is ft, f of t times your du. This is du is equal to minus s exponential minus s minus s exponential minus s dt. True or false? Okay? So if you agree with me, if you can see